Thank you for joining us today to talk about the benefits and challenges of hybrid cloud and how many of those challenges can be overcome by Microsoft's Azure Stack platform. My name is Chris Patterson, and I have spent the last 15 years as a cloud product director at various service providers. I've had a front row seat to the evolution of cloud computing platforms and the opportunities and benefits that they provide in the market. I am fortunate to be joined today by my colleague, Kris Turner, who is a highly accomplished cloud architect and one of the few Microsoft MVPs in the world for hyperconverged infrastructure. Kris will be sharing his expertise about the Azure Stack platform. We have a fairly compact agenda today. We will start by discussing the nature of hybrid cloud and all of the benefits that can be achieved and challenges faced by embracing both public and private cloud architectures together. From there, Kris will provide a deep dive on the Azure Stack platform and how it can help to reconcile many of those challenges. We will then close with a little bit of Q&A. When we look at cloud platforms, there are a few key areas of differentiation: scalability, cost efficiency, security, and innovation. With a private cloud, you are limited in scale to the servers, storage, or other capacity that you purchase up front. In a public cloud, you can scale up and down as your business needs change. This means that an accounting firm can double their compute resources for tax season, but then drop them back to a lower level in May. This means that that accounting firm would only pay for what they use in a public cloud model, while for private cloud, they would pay a predictable amount for all available capacity. This should mean that public cloud is more efficient, but in practice, achieving that efficiency is a full-time job. The number one public cloud challenge cited in most polls is cost control. In addition, many steady-state 24/7 types of workloads can actually run more cheaply on private cloud if there are a sufficient number of them. When it comes to security, let me say from the outset that neither public nor private cloud software is inherently more secure than the other. When properly configured, both can protect you from most threats, but both are also susceptible to future zero-day attacks. The primary difference when it comes to security is whether you want to put the onus for secure configuration monitoring of the infrastructure in the hands of Amazon, Microsoft, or Google engineers, or whether you want to manage that yourself. Finally, when it comes to innovation within the platform, public cloud delivers at a much higher velocity. A quick perusal of the Azure Updates site shows that they have dozens of new releases or announcements each week, while VMware or Nutanix deliver larger amounts of improvements and enhancements just a few times a year. This higher rate of innovation on public cloud provides tremendous opportunities to an IT team that can quickly take advantage, but can be overwhelming for those who need to make sure that automation or other integrations continue to work predictably. This brings us to the hybrid model. Hybrid acknowledges that cloud doesn't need to be public or private. There is no one-size-fits-all. Hybrid recognizes that the SAP system runs best on single-tenant hardware. Marketing campaign websites can quickly come and go on public web services, and you are never going to run an email server more efficiently than O365. Hybrid lets you match each of your workloads to the cloud architectures that can serve it best, but it's not without its challenges. Traditionally, the biggest problem with hybrid cloud has been that there was no single interface or provider that could do both well. Many companies have tried to build portals and other interfaces to bridge the gaps, but the more functions they tried to do, the less effective they became at each. This is manifested in a few areas. First off, integrating public and private is very challenging from a technical perspective. While we use common names for objects like VM, the manner in which they are built and managed by the underlying platforms vary greatly, so something as simple as adding more vCPUs or disks could have very different requirements or effects. Coupled with the unpredictable changes to APIs and other interfaces from multiple vendors, just being able to perform basic management tasks can be a big challenge. Secondly, different platforms have different approaches to security and different tooling. A VMware-based security solution may be very effective when just running on VMware, but when you need to tie it into an AWS environment, there may be the need to open it up far more than a VMware security engineer intended. The same goes for any other third-party product that may have been designed for one system and then only loosely ported to another. Cost management and optimization are significant challenges on public cloud, where an invoice for even a simple environment can have dozens of charges. Within a hybrid environment, it can be difficult to compare the costs of the two different cloud types in order to determine the most cost-effective location for a given workload. Tracking all of these costs usually results in a very large Excel spreadsheet that provides more confusion than clarity. In a similar manner, different platforms use different tools for monitoring of performance and security issues. It can be hard to track where a problem is occurring if you have to look through multiple portals and sets of log files. Tools do exist for performance management across multiple platforms, but that becomes just another tool that you have to pay for and manage. Finally, all of these platforms need to be configured and managed, and most of us never really get the headcount that we want at budget time. Asking an already overworked IT team to have deep knowledge of multiple platforms simply isn't fair. So how can we best take advantage of hybrid cloud and in the face of these challenges? Fortunately, there's Azure Stack. Azure Stack is the platform that only Microsoft could build. Microsoft has been in the corporate data centers for almost 30 years, and their Azure platform is one of the top public clouds in the world. They are uniquely suited to understand and address the requirements of both the fast-moving DevOps types of workloads, as well as the more measured pace of a very mature organization. When it came to designing Stack, Microsoft didn't try to blend the two types of cloud, but rather designed Stack to be a much smaller version of its Azure platform, while retaining the same configuration, management, and monitoring methodologies. This means that the same Azure interface that admins and developers already know and love can be used to control workloads within a private data center as well. By simplifying and unifying all operations within a common framework, public and private workloads can truly be treated in a side-by-side manner. I will now hand the mic to Kris Turner, who will share exactly how Azure Stack is able to meet these goals.
Thank you, Chris. Let's explore Azure Stack HCI and its integration with hybrid cloud solutions, focusing on how Azure Arc enables seamless connectivity and management across diverse infrastructures. On this slide, we see the comprehensive capabilities of Azure Arc, which allows us to connect, manage, and operate any infrastructure with consistent tools. Let's talk about the reach. Azure Arc extends our reach to both Windows and Linux environments, whether they're running on virtual machines or on bare metal. It provides us a scalable, searchable inventory across all our resources, making it easier to manage our entire infrastructure. Next, let's talk about configuration. With Azure Arc, we can ensure consistency across virtual machine extensions, enabling standardized configurations. We could talk about centralized agent management for monitoring, for security, for update management, which simplifies operations, ensuring that all systems are up to date and they're very secure. Excuse me. Next, let's talk about governance. Azure Arc includes built-in Azure policies that can help maintain compliance across different environments. We can audit and enforce operating system settings, ensure that all systems adhere to corporate and regulatory standards. And finally, let's talk about security. Security is paramount, and Azure Arc leverages intra-ID managed identity for robust authentication and authorization. Let's talk about server security baselines and how role-based access control could further enhance the security posture of our infrastructure. By leveraging Azure Arc, we can unify a management approach across various platforms, from AWS to Google Cloud to VMware and on-premise environments such as Azure Stack HCI, ensuring a consistent and secure operational model. Let's discuss the platform architecture of Azure Arc and Azure Stack HCI from the bottom up, highlighting how each layer contributes to a cohesive and unified hybrid cloud environment. At the foundation, we have the hardware ecosystem. Azure Stack HCI supports a broad range of hardware, offering flexibility and choice for deployment. This layer ensures that we can leverage the infrastructure that best meets our performance and scalability needs. Above the hardware, we have the Azure Stack HCI operating system. This OS provides the core functionalities for running virtualized workloads, offering robust support for high availability, performance, and scalability. It forms the backbone of our hybrid cloud infrastructure. Moving up, we see the support for both Windows and Linux virtual machines. Azure Arc extends its capabilities to manage these VMs, providing a unified experience regardless of the operating system ensuring a consistent management and consistent operations. Next, we have our hybrid deployment of Azure Kubernetes Service, AKS. This allows us to orchestrate and manage containerized applications seamlessly across on-premise and cloud environments, leveraging Kubernetes' powerful capabilities. Containers are a crucial part of the modern application deployment. Azure Arc facilitates the management of containerized applications, ensuring that they are efficient and scalable. This supports a microservice architecture and modern application practice. And then we have our Azure Arc enabled data services. Azure Arc enabled data services such as SQL are highlighted next. These services are robust database solutions that can be consistently managed across different environments, providing flexibility and reliability for our database needs. We then see the support for cloud-native applications with a variety of programming languages and frameworks, including Go, Node.js, .NET Core, Python, C++, and Java. This enables developers to use their preferred tools while benefiting from Azure's robust management and operational capabilities. And then at the very top left, we see the virtual machine applications. At the top layer, we could see that the virtual machines and key applications like SQL Server, Exchange, SharePoint, these critical enterprise applications are well integrated into the Azure ecosystem, ensuring that they are managed and operated efficiently within our hybrid cloud strategy. By leveraging Azure Arc, we can create a comprehensive and integrated hybrid cloud environment, managing everything from hardware to applications within a unified Azure framework. Let's take a closer look at the layer of security built into Azure Stack HCI, starting from the top and moving down through each layer. First, we have the security operate your workloads. So at the top, we have Microsoft Defender, which provides comprehensive protection for servers, SQL servers, domain controllers, virtual desktop infrastructure, containers, and Kubernetes. This ensures that all the workloads are securely operated with industry-leading defense mechanisms. On the next layer, we have our simplified operational hardening. This layer focuses on making security easier to manage and implement across operations. Key features include confidential compute, privileged access, and network security using software-defined networking. On the third line, trustworthy addition to our environment. Ensuring that all additions to our environment are trustworthy and secure is crucial. This layer includes encryption and data protection, and system security and zero trust. On the fourth line, we have our silicon-assisted security. At the hardware level, Azure Stack HCI leverages silicon-assisted security measures, starting from hardware roots of trust with technologies like TPM 2.0, Secure Core, and finally, the fifth line, enabling regulated customers. Finally, for customers in regulated industries, Azure Stack HCI provides additional assistance with security certifications and supply chain measures that are in place to ensure that the integrity and security of the hardware supply chain from manufacturer to deployment. Then on the right side of the slide, we see key points highlighting the strengths of Azure Stack's HCI security, from industry-leading built-in security to security built-in for the Azure Data Center, and then the silicon-assisted security. In summary, Azure Stack HCI offers a multiple-layer security approach, from operational hardening to silicon-assisted protections, ensuring that our infrastructure is secure, compliant, and trustworthy. Azure Site Recovery, ASR, is a powerful service that enhances the resilience of Azure Stack HCI environments by providing continuous replication and seamless failover capabilities. Here are some of the summaries of what Azure Site Recovery can do for Azure Stack HCI. Workload replication. ASR replicates workloads running on Azure Stack HCI to Azure, ensuring that business-critical applications and data are continuously backed up and protected. Business continuity. In the event of a disruption, ASR enables quick failover to the Azure cloud, minimizing downtime and ensuring that your operations continue smoothly. Secure data transmission. Data replication is carried out securely using HTTPS over port 443, maintaining data integrity and confidentiality during transition. Integration with Azure Stack HCI. Azure Stack HCI ASR, of course, integrates seamlessly with Azure Stack HCI, making it easy to set up and manage the replications across your hybrid cloud environments. In essence, Azure Site Recovery provides a comprehensive solution for protecting Azure Stack HCI workloads, ensuring that your critical infrastructure is resilient, secure, and always available. Let's talk about the Microsoft Azure Backup Server, commonly known as MABS. MABS plays a crucial role in delivering backup and restore services for various resources, including host, guest, and Hyper-V virtual machines, as well as file, system state, and SQL application backups. It supports both Windows and Linux operating systems, making it a versatile tool for our backup strategy. When it comes to storing backups locally, MABS uses storage available on the designated appliance. This allows for quick recovery of the data and minimizes downtime in case of any issues with the original source. In addition to local storage, a copy of our data is also stored in the Azure Recovery Service Vault. This vault can be configured with different redundancy options, including local redundant storage, geo redundant storage, and zone redundant storage, ensuring that our data is protected according to our specific needs. And of course, security is paramount. An Azure Backup ensures that your data is encrypted at rest in the Recovery Service Vault. This encryption is managed using Microsoft keys, providing an additional layer of protection against unauthorized access. Now let's discuss policies, specifically the frequency and retention standards that Azure Backup adheres to. For local backups, it's best practice to retain them for about 3 days. Meanwhile, a backup copy is sent to Azure Recovery Services Vault daily and retained there for up to 14 days. This dual layer approach ensures that you have quick access to recent backups while also maintaining long-term copies for compliance and disaster recovery purposes. Monitoring your backup is critical. An Azure Monitor is integrated with Azure Backup to provide real-time insights into the health and status of our backup jobs. This ensures that any issues are identified and addressed properly, reducing the risk of data loss. Finally, standard reporting features are available, offering detailed reports on backup job success and failure rates. These reports are crucial for maintaining compliance, auditing purposes, and ensuring the overall reliability of our backup strategy. To sum it up, Azure Backup is a powerful, secure, and flexible solution that helps us protect your data, whether it's on-premise or in the cloud. By leveraging MABS and the Recovery Service Vault, we can ensure that our data, your data, is always available, secure, and compliant with our organization's policies. Now, back over to Chris Patterson.
Thank you, Chris. Microsoft has taken great pains for Azure Stack to be as easy to use as possible and has provided an almost infinite level of flexibility in how it can be deployed. Flexibility is important in being able to efficiently meet your IT requirements, but it takes experience to be able to configure the platform in that optimal manner. TierPoint is a strong Microsoft partner with a rich history of providing solutions both within our data centers and in Azure. We have a strong bench of engineers and architects who not only keep to date on the ever-evolving Azure platform, but also have experience in matching those innovations to customer needs. Our large customer base and broad collection of individual and company certifications mean that we don't have to guess at how to fix your issues because we've likely seen it before. When it comes to hosting for the physical Azure Stack servers, TierPoint is second to none. We have found that many of our customers have grown tired of maintaining their own data centers with all the costs and hassles of generators, biometric security systems, and giant HVAC units. TierPoint operates 40 data centers across the country with high-speed connectivity between each other and to the Azure cloud. We can host Azure Stack servers or any other gear securely within our facilities so that our customers can sleep at night. Our long partnership with Dell has provided us with access to the tightly integrated ACP for Azure Stack platform. This is a set of hardware that has been designed and optimized by both Dell and Microsoft engineers who are responsible for testing all patches and firmware on that hardware before they are released. This minimizes the chances of conflicts between software drivers or other minor issues that result in major pain. For those who do not have deep expertise when it comes to Azure, or for those who have some but are looking for a little bit of help along the way, TierPoint offers an array of managed services. This can be anything from the ability for your engineers to call for help with an issue, all the way up to full management of the Azure platform. We recognize that everyone is in a different place on their cloud journey, and everyone has different priorities for their IT teams. My personal observation is that most engineers can configure an environment properly or resolve an issue given enough time to dig into it, but time is the most precious commodity for that team. If you would like to focus your team on building out that new application or delivering on more strategic goals, TierPoint will be happy to do the rest. And with that, we have come to the end of today's webinar. Hopefully, you have found this to be informative, but if you have any additional questions about Azure Stack or any other IT needs, please reach out to us at our website or via the phone number below. Thank you for listening and have a great rest of your day.